Solving systems of linear equations in two variables by graphing method. Now, we know that the solution of a system is an ordered pair of numbers x, y that is a solution to both equations in the system. So, the solution of the system is the solution that is a solution to both equations on the system. So a common solution is a solution for the system that these two equations form. Now, we know that an ordered pair of numbers in x and y is a point on the coordinate plane. What this means? That means that a solution to the equation is a point on the coordinate plane. So since the linear equation in two variables has infinitely many solutions, we expect infinitely many points on the coordinate plane, and those points are consecutive points. So infinitely many solutions, infinitely many points on the coordinate system, and we connect those points with a line, and the line represents all the solution to the equation, which means each solution to equation is a point on a line, and each point on the line is a solution to the equation. So now that we have two equations in the system, okay, we are asking how many solutions such a system has. In other words, geometrically, which is the goal of this video, means how many points in common the lines that represent the equation of the system will have. So, and we have three cases. When the equations, the graph of the equations are two lines that never intersect each other. Because they are parallel, this means they do not have a common point. Since they do not have a common point, they do not have a common solution, so the system doesn't have a solution at all. Sometimes the lines represented by the equations of the system intersect at one point. That means this intersection point is the common solution. So, since it is the common solution because satisfy the equations of both lines, it is the solution of the system. And this is the only one, a unique solution for the system. Sometimes the lines go and match each other. So what this means? We say the lines coincide, which means that the lines represent both equations of the system represent the same line, which means they have infinitely many common points, which are solutions to both of this equation. So both equations in the system have infinitely many common solutions. So the system will have infinitely many solutions also. Now, let's go and work on the problem 1. Solve the given system by graphing. So what this is telling us, since we have two equations in two variables in the system, we have to draw two lines and to see which case will be. If the lines are parallel, we will say that the system has no solution. If the lines intersect at one point, we will say the system has only one solution. If the line coincides, then we'll say that we have infinitely many solutions for the system. Now let's see what these two lines will behave. Now, let's use the table method to find some solutions for the equation, which will be points on the plane. And if we have points on the plane, we will connect those points and we'll draw the line. We need at least two solutions in order to have 2 points. Sometimes we need 3 solutions. Now, if I give a value for to x, if I make x 0, so 0 times 2 is 0, so y is 7. If I let x be 1, so 2 times 1 is 2, going to the other side with a negative sign, so we have 7 minus 2, 5. If I let x to be 2, so 2 times 2 is 4, and 4 to the other side will be negative, so 7 minus 4 is 3. So I found 3 points. 0, 7 for the first equation, 1, 5 and 2, 3. Now I'm going to plot those points, and 0, 7 is here, 1, 5 is here. So this was 0, 7, this is 1, 5, and 2, 3 is here. 2, 3. So 2, 3, 2, 3. Now 3 points will give me the line that represent the first equation, which is the graph of all solutions of the first equation. Let's name this L1. And now let me go and plot the graph the second equation. So if I leave x 0, that means 0 times 4 is 0, so y will be 0. If I leave x 1, 1 times negative 4 becomes negative 4, and negative 4 divided by 2 is negative 2. If I leave x negative 2, so I will have negative 2 times negative 4, positive 8, and positive 8 divided by 2 is 4. So now I have 3 points for the second line, 0, 0, 1, negative 2, negative 2, 4. So as we said before, the solutions are ordered pair of numbers, and now these will become points on the line, because this is the graph of a point on the plane. It's just of this is the graph of an ordered pair in the plane. It's just a point. So 0, 0. We know this, but it's good to repeat. 1 and negative 2. So x is 1 and y is negative 2. So this point is here. So this was 0, 0. This is 1, negative 2. And I have negative 2, 4. And I have x negative 2. And y will be 4. I have 3 points, enough to draw the line that represents the second equation. Let's call this L2. And now we see from the graph that the lines are parallel, so they will never intersect each other, so they will have a common point, and therefore they will never, the equation that represent these lines will never have a common solution. So for the system we have not a solution. So by graphing, we say no common points for the graphs of equations on the system. Therefore, no solution for the system. That's it. So the first system do not have a solution, and this happens often. Now, let's look at the example 2. Let's read the equation. 2x minus y is equal 8. 6x plus 3y equals negative 24. So I use x and y intercept point. So I will use x and y intercept points here. And I know, what does it mean? Let me write the first equation. 2x minus y equals 8. And I will leave x equal to 0, and I will get a value for y. When I leave y 0, I will get a value for x. Let's write two equations, one for x. So 2x is equal to 8. Because I let y equal to 0, y disappear. And dividing by 2, x is 4, which is the x-intercept point. Okay, this is 4, 0. Now I will leave an equation for y, leaving x, let x be 0, so I have negative y equal 8. Dividing by negative 1 both sides, I have y is equal to negative 8, and this is 0, negative 8, the y-intercept point. Plotting these 2 points, I have 4, 0, and I have 0, negative 8. Connecting the 2 points, I don't need another point. Let's name this L1 because this is represented by the first equation. Let's rewrite the second equation, negative 6x plus 3y equal negative 24. Still again, I will do the same thing. Okay, so I will leave y equal to 0, so 3 times 0 this is 0, so I have only an equation on x. Dividing by negative 6, both sides, I have x equal to 4, and I leave x 0, x 0 times negative 6, 0, so I have only an equation for y. So 3y is negative 24, dividing by 3 both sides, I find that y is negative 8. Very beautiful. I'm observing right now that both lines have the same x-intercept point and exactly the same y-intercept point. So what this means that when I'm going to draw the second line is the first line. And we say the lines coincide because both equations are representing the same line. So this line contains all solutions for both equations. Infinitely many common points, which are infinitely many common solutions for the equations of the system. So by graphing, the lines appear to coincide. Therefore, the system has infinitely many solutions. Now, for the first example and the second example, I didn't check the solution, okay? But usually we check the solution. For the first equation, we didn't have solution, so we didn't what to check. But now we have infinitely many solutions. So how to check that this is the right line? Just check one point to both equations and you will find true statements, okay? But I am not checking because I think that I did the correct work, okay? And those values came from the equation also, but the rule is that we have to check the solution. So choose a solution, check to both equations, and then we are correctly saying that this equation has infinitely many solutions. So here we have to check both the solutions. Now, let's go to the third system. So let me choose, now I have x minus 2y equal 1, x plus y equal to 1, so it's very easy to use a table of values here. So if, let's start with the first equation. So if I leave x equal to negative 1, So negative 1 will go to the other side as a positive 1. So I have 2 divided by negative 2, so y will be negative 1, and I have a point negative 1, negative 1. Now, if I leave x to be negative 3, so negative 3 will go to the other side and will be positive 3. So I have 1 plus 3, 4, divided by negative 2, and I find a value for y, which is negative 2. So I have a point here, a pair of numbers in order, which will be points. But we usually say points because they are points, because we are looking for the graph of this pair of numbers. Now, if I leave x equal to 1, 1 will go to the other side as a negative 1, because positive 1 will change the side, change the sign. So now 1 minus 1 becomes 0. Now, if I choose that x is 5, 5 will go to the other side as a negative 1. So 1 and negative 5 is negative 4. And negative 4 divided by negative 2 becomes positive 2. So now I have 4 points here. And I'm going to draw the first line. So negative 1 is here. X is negative 1, y is negative 1. Negative 3, negative 2. So negative 3 is x and negative 2 is y. So I have another point here. Negative 2, negative 3, sorry, negative 2. So I have 1, 0. When x is 1 and y is 0, I am here. So 1, 0. Really, I don't need another point, but let me do this. 5, x is 5 and y is 2. So x is 5 and y is 2. I have the point 5, 2. So I have 4 points. Let me connect those two lines. These 4 points with a line. And I have the graph of the first equation. So let's call this L1. Now I need to draw the second line. Let me choose, this is very easy. So when I leave x 0, y becomes 4. When I leave y 0, x is 4. So I have 2 points, which are intersection points. This is y-intersect point. This is x-intercept point. And now, let me see if I need another point. If I don't need another point, I will not find another point. Why? So 0, 4. And 4, 0. If I need a point, I can choose a value here to give me a point. And if I want a point in this side, I can choose a value for x here and find another point. I don't need, in this case, this is enough. So this is the graph of the equation, of the second equation. And now I see that the lines intersect. Now I know that the intersection point will be the solution for my system, and I need to find the values of the coordinate. So x is 3 and y is 1. And now I declare that by graphing the lines appear to intersect each other at point 3, 1. Therefore, 3, 1 is the solution of the system. Okay, so based on my graph and my work, I now declare that yes, the system of equation has a unique solution because the lines intersect exactly at one point. and the point of intersection, the values of this point is the solution to the equation. Now, to the system. Now, if I want, let me check here. Check the solution. So I have to check the solution to both equations. So let me write both equations. And the second is x plus y equal 4. I am declaring that 3, 1 is a solution. I have to check it. So what this means? I have to substitute x with 3 and y with 1. So I have 3 minus 2, and 3 minus 2 is 1. So what I have 1 equal 1, true statement. So the solution that I pretend to be the solution of the system satisfied the first equation. And now let me check to the second equation. So replacing x by 3 and 1 by 1, I have 3 plus 1, 4. And now I have 4 equal 4, which is a true statement. That means that my solution satisfied both equations of the system. Therefore, 3, 1 is the solution to the system. This solution. Now I'm done. So graphing method is very easy. Draw the lines, observe the lines, and the lines will tell you the truth, if the system has a solution or not. We know that the points on the lines are solutions of the equations that are in the system. Now, for example 4, I will not work. I only want to show that not always the graphing method works, because as we see in this example, the point of intersection, okay, which is x, y. Now, x and y are not integers, so the values of the solution are not integers. So I need the help of algebra, and two other methods are methods that we use algebra. We solve the system algebraically. Now, why we need algebra in this case? Because even though you use a graphing calculator and you find the coordinates of this point, sometimes the graphing calculator will give you a value for x or for y, which will be maybe a rational number, maybe decimal numbers that you can convert into fractions, or maybe they will be irrational numbers, so you cannot convert them to fractions, and to declare the exact solution. They will give you approximately solution. We are looking for the exact solution, so by algebra we can give the exact solution. It doesn't matter the solutions are rational number or irrational number. Okay, so thank you very much. I hope this will help you to do the homework, and see you on the next video.